Hey everyone, welcome to Simplicode's YouTube channel. In today's session, we'll go through World Happiness Report 2021 using Python. World Happiness Report is basically a survey of state of global happiness that ranks various countries around the world. Some of the factors that are taken into consideration for the report are social well-being, work-life balance, life expectancy, and other life factors. It also focuses on the COVID pandemic and how it impacted people's lives. So in this tutorial, we'll analyze and visualize a data set and derive insights on World Happiness Report using Python libraries. But before we begin, make sure to subscribe to our channel Simplicode to stay updated with the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started.
The International Happiness Day is celebrated every year since 2013 on 20th of March to emphasize the importance of happiness in the daily lives of people. So the United Nations Sustainable Development Solutions Network published the World Happiness Report on 19th of March 2021 that ranks the world's 149 countries on how happy the citizens perceive themselves to be based on various indicators. The happiness study ranks the countries on the basis of questions from the Gallup World Poll. The results are then equated with other factors such as GDP, life expectancy, generosity, etc. This year it focused on the effects of the COVID-19 pandemic and how people all over the world have managed to survive and prosper. So using this 2021 data, we will answer critical questions such as the top 10 most corrupt countries. We will plot a graph to understand how the happiness score is related to the freedom of making life choices. We'll look at the life expectancy of 10 happiest and 10 least happy nations. So these are a few examples, but we will explore more about the data in detail in our demo session. Let's get started. So first I'll show you the data set we'll be using in this demo. So this data has been collected from Kaggle. Let me show you that. So this is the CSV dataset that we have downloaded from Kaggle.com. So you can see here World Happiness Report 2021, and we will share the dataset link in the description of the video. You can click on the link to download the dataset. Now we have information about 149 countries. You can see it here. Count is 149. Let me go to the top and I'll run through the columns that are there in this dataset. So the first column is the country name. So we have 149 different countries, and then we have something called as regional indicator. We can call this as just the region. So you can see we have different regions. I've applied a filter. We have Central and Eastern Europe. Then we have Commonwealth of Independent States. So these include countries such as Russia. Then we have East Asia, Latin America and Caribbean. We also have South Asia, Southeast Asia, Sub-Saharan Africa, Western Europe and other regions. I'll just cancel this. And then we have the happiness score column that has been sorted in descending order. So we have Finland, Denmark and Switzerland, who are the top 3 happiest nations. Now if I scroll down, we have countries like Rwanda, Zimbabwe and Afghanistan, which are the least 3 happy countries. Now there are a few columns that we won't be using in our analysis, so we will learn how to exclude those columns and keep only the relevant ones. So columns such as standard error of ladder score, then we have upper whiskers and lower whisker column. So we are going to ignore these columns. We are only concerned about the GDP column, which is this one. Then we have the social support or the social status column. Then we have the health life expectancy, freedom to make life choices, generosity and perceptions of corruption. And there are a few other columns you can see to the right, and these columns are not of our interest, so we are going to ignore them. Now let's head over to our Jupyter notebook and we'll start by importing all the necessary libraries for analysis and data visualization. Okay, so I'm on my Jupyter notebook. So first step, I'll just rename this notebook to, let's say, Happiness Report Data Analysis. I'll click on rename. Alright, now we'll start by importing our libraries. So first library I'm going to import is numpy as np. Then I have import pandas as pd. Then I'll import two data visualization libraries, seaborn and matplotlib. So I'll say import seaborn as sns, and then import matplotlib dot pyplot, which is the module name, as plt, and I'll say percentage matplotlib inline. Okay, now let me just go ahead and run this. Alright. Well, now let's set the parameters that control the general style of the plots. The style parameters control properties like the color of the background and whether a grid is enabled by default or not. So for that, I'll say sns dot set underscore style. I'll give it as dark grid. Next, I'll say plt dot rc params, which stands for runtime configuration parameters. I'm going to set my font size to, let's say, 15. Then I'll say plt dot rc params. Now I'm going to set the figure size, so I'll say figure dot fig size. Let's say 10,7. Next, I'll just copy this, paste it here. Now we are going to set the face color, so I'll say figure dot face color. I want to set it to peach color, so I'm going to pass in my RGB values for peach. I'm going to set it in terms of hex code. So for peach, the value is FF E 5B and 4. Now let me run it. Okay. Now it's time to load our data set. So for that, I'll create a variable called data, and I'll use the pandas library followed by the read underscore CSV function, because our data set that we saw is a CSV data set, which is this one. Now inside the parenthesis, I'll pass in the location of my data file. So I have my data here, World Happiness Report 2021. I'll just copy this location and will paste it here, and make sure the location is within quotes, and you need to change it to either / or double backslash. So here I'm using double backslash, so let me just include one more backslash, and then I'm going to pass in the file name, which is world happiness report 2021 .csv, which is the extension of the file. Now let me run it. Alright, now to display the first 5 rows of information, you can use the head function. So I'm writing data, which is my variable that holds the data frame. So data.head, there you go. You can see here we have printed the first 5 rows from the dataset. You have the country name, regional indicator, happiness score. Then we have information about the GDP, life expectancy, generosity. Then we have corruption data and These are some of the columns that we are not bothered about, so we are going to drop these columns from our analysis. Now we are going to do that, so I'll create a variable called data columns which are of our interest. So I am going to take only specific columns. I need the country name, so I have taken country name. Make sure the column names are within single quotes. So I have my country name. Next I want the second column, which is regional indicator. I'll give a comma. We also need the happiness score. Next I need the logged GDP per capita data, so I'll take that column. I'll say logged GDP per capita, give a comma. My next column would be social support, give a comma here. My next column would be health life expectancy, so I'll write health life expectancy. Let's give another comma, and we'll take the next column as well, which is freedom to make life choices. So I'll write that column name, freedom to make life choices. And finally we'll take the next two columns, that is generosity and perceptions of corruption. So within single quotes I'll say generosity, give a comma, and we're going to include the final column which is of our interest, that is perceptions of corruption. Let me have a recheck to ensure that I have put the column names correctly, otherwise it will throw an error. Now let me go ahead and run this cell. I'll hit Shift Enter. Alright, so we have successfully taken the columns that we'll be using for an analysis. Now I'm going to say data equal to data. I'll pass in my new variable, that is data underscore columns, and I'm going to copy all the data. So I'll say dot copy. Let's run it. Okay, this should be data underscore columns. Alright, now let's rename all these columns. We'll make it more simpler and easy to understand. So I'll say, let's say my new variable is happy underscore df, which stands for data frame, equal to, I'll say data dot, we'll use the rename function, and using a dictionary we will rename our columns. So I have used a curly bracket. I'm going to pass in my first column, which is country name. I'll just paste it here. Then I'm going to give a colon, and again within single quotes I'll say country underscore name. So this is going to be my new column name. I'll give a comma. We'll take the next column, which is regional indicator. I'll paste it here, give a colon, and the new column would be small r regional underscore indicator. Now similarly we'll do this for all the remaining columns in the dataset. Okay, now I have renamed all my columns. You can see it here. Let's run it. Now we are going to display the head of the dataset again. So I'll say happy underscore df dot head. There you go. So we have only those columns that are of our interest. So I have the country name, regional indicator, happiness score, GDP, social support, life expectancy, freedom to make life choices, then I have generosity and perceptions of corruption. Cool. Now we are going to check whether any of the columns have any null values. So for that I'll say happy underscore df dot, I'm going to use the isNull function. I'll give another dot and we are going to find the sum for each of the columns. You can see from the data we do not have any null values in any of the columns in the data set. It is all 0. Okay, now let's get started with our first visualization, that is we'll create a plot between happiness score and the GDP for different regions. So for that I'll give a comment as plot between happiness and GDP. I'll just scroll down. Cool. First I'm going to set the RC parameters. So I'll say plt dot RC params. Within square brackets I'm going to give my figure size. So I'll say figure dot fig size equal to, let's say my figure size is 15,7. I'll set the title, that is plt dot title of my plot, to, let's say, plot between happiness score and GDP. Next I'm going to say SNS dot, let's create a scatter plot. So I'll say SNS dot scatter plot. I'm going to define my x-axis and the y-axis for the plot. Let's say in the x-axis we have my data frame happy underscore df dot, this should be an underscore. I'll say a column name as happiness underscore score, give a comma, and in the y-axis we'll have my data frame name, that is happy underscore df dot, we'll have the GDP column, that is logged underscore GDP underscore per underscore capita. Let's give a comma and we'll pass in hue for the color. Let's say for hue I'm going to use the regional column or the regional indicator column. So I'll say happy underscore df dot regional underscore indicator. And then I'm going to give the size of the dots as, let's say, 200. Then I'll give a semicolon. Come to the next line. I'll say plt dot, let me just scroll down. Now we are going to define the legend. So I'll say plt dot legend, and in legend we'll have the location. Let's say I want to put the legend at upper left corner. So I'll say LOC, which is for location, equal to upper left, give a comma, and then say font size of my legend, let's say be 10. Make sure this is within quotes. Then I'm going to pass my x-axis labels and the y-axis labels. So I'll say plt.x label. Let's say the x label is happiness score and my y label is GDP per capita. So I'll say plt.y label, within single quotes I'll say GDP per capita. There's an error here, there should be plot. Alright, so I have written my code to create a scatter plot. Let's run it and see the result. There is some error here. Okay, this should be regional indicator and not indicatory. There's a spelling mistake. Let's run it again. Alright, so here you can see we have a nice scatter plot. On the top you can see we have the title of the plot, that is plot between happiness score and GDP. On the x-axis we have the happiness score from 0 to 8 and above, and on the y-axis you have the GDP per capita. And if you see here, in this region we have countries from Western Europe which have the highest happiness score, and the GDP per capita is also the highest. Around this region you can see here, which is for green, and in the legend you can see green is for sub-Saharan Africa. So all these countries have low happiness score, and even the GDP per capita is also low. And if you see the countries for Latin America and Caribbean, you see a lot of the values lie here. So they are all within the range of 5.5 to 7 in happiness score, and even the GDP per capita is more than 9 for most of them. Now even the happiness score is high for the countries that lie in the North America and ANZ region, and even their GDP per capita is also the highest. I can name a few countries such as Australia, New Zealand, we have Canada and United States of America, which belong to the North America and ANZ region. Cool. Now there is one country which you see here. This seems to be like an outlier, which means that this is the country which has the lowest happiness score, and even the GDP per capita is also low, but it is not the lowest, because you can see here there are a few countries up here from the sub-Saharan Africa which have the lowest GDP per capita, but the happiness score is higher than this value or this country. So we can assume that this country is Afghanistan, which has the lowest happiness score as per the 2021 happiness report data. Cool. Now we'll plot a pie plot to understand the GDP by region. So by this we can know which region has the highest percentage contribution to the world's GDP as per our data. So for that I'll create a variable GDP underscore region equal to, we'll use our data frame, that is happy underscore df dot, I'm going to use the group by function, and after that I'm going to use my column, that is region. So we have named the column as regional underscore indicator, so I'm going to group it by this region column, and I'm going to sum the values of GDP. So I'm going to use the logged underscore GDP underscore per capita column, and after that I'm going to use the sum function, and let me just print GDP underscore region. You can see it here, we have the sum of all the countries for different regions and their GDP all total. Now this data we are going to plot it in the form of a pie plot. So I'll say GDP underscore region dot plot dot pie. We are going to plot it in terms of percentage, so I'm going to use a parameter called AutoPCT equal to, then I'm going to pass in my format. So I'll say percentage 1.1 f percentage, then I'll say plt dot title. Let's say the title of my pie plot is going to be GDP by region, and I'll say plt dot by label. which is going to be blank. Let's run it. Okay, so here you can see we have the peach background at the back because we had assigned a peach face color. You can see it here. So for the first scatterplot also we had the peach color at the back, and now you can see we have Sub-Saharan Africa contributing 20.7% to the world's GDP. The reason being we have around 34 countries in the Sub-Saharan Africa, and we have the Western European countries contributing to 16.2% of the GDP. To check the least, we have North America and ANZ region because we only have 4 countries: America, Australia, Canada and New Zealand. So hence they are contributing only 3.1% to the world's GDP. Okay, now moving ahead, let's find the total number of countries in each region. So for this we are going to use the group by function that is part of the pandas library, and we'll count the total number of countries in each region. So I'll just give a comment as total countries. Alright, I'll just scroll down. So I'll create a variable called total underscore country. I'm going to use my data frame that is happy underscore df dot. I'm going to use the group by function. I'll group the values based on the region column. So within single quotes I'll say regional underscore indicator, and then I'm going to find the total count of country names. So I'm using the column country underscore name, and after that I'll just use dot count. Now let's go ahead and print my variable that is total underscore country. Alright, now let me hit shift enter. Okay, so here you can see. Alright, so for Sub-Saharan Africa there are total 36 countries and not 34 as I mentioned earlier. So hence you can see, because it has the highest number of countries, it is contributing the most to the world's GDP, that is 20.7%. Then we have the least number of countries in North America and ANZ, that is only 4. We have 6 countries in East Asia, and then we have 20 countries in Latin America and Caribbean, 12 countries in Commonwealth of Independent States, then we have 17 countries in Central and Eastern Europe. Cool. Now I'm going to show you how to create a correlation map so that we can see the relationship that exists between each of the variables that are present in our dataset. I'll just run through the code and we'll see the output. Okay, so here I have my code written for the correlation map that I want to create. So first of all, I'm going to compute the correlation matrix. So I have used the CORR function, which stands for correlation, and the method I'm going to use is Pearson method. Now here I have a Wikipedia page opened for Pearson correlation coefficient. So this is a nice article where you can understand what the Pearson correlation is all about. And then I'm going to set up the matplotlib figures. So I have used the subplots function and I have given the figure size as 10,5, and after that we are going to draw the heat map with the mask. So I am using the heat map function present in the Seaborn library, and then I have passed in my variable that is COR, which essentially stands for correlation, and then I have used mask, which is a Boolean array, or it can be a data frame, and it is an optional parameter. If it is passed, the data will not be shown in cells where the mask is true, and the cells with missing values are automatically masked. After that, I have used the CMap parameter, which stands for color map, so you can customize the colors in your heat map, and I'm going to create a heat map which is in square shape. So I have said square equal to true, and the axis I am going to pass it as AX, which I have defined here. So this is the matplotlib axis and it is optional. So axis in which you want to draw the plot, otherwise you can use the current active axis. Now let me just go ahead and run this and we'll see the heat map. There you go. So if I scroll down, here we have the correlation matrix, and since I had given my C map as blue, and here you can see it is mostly blue, and we have the scale here. Now I'll tell you how to read this correlation matrix. So wherever the cells are in blue or dark blue color, this means that the variables have very high correlation, and all these cells where you see light blue color or grayish and white color, this indicates that the variables have very low correlation. For example, there is very low or almost negative correlation between happiness score and perceptions of corruption. So obviously if the citizens of a country feel that there is a lot of corruption in the country, their happiness score would obviously be less or low. And if you see, there is also low correlation between happiness score and generosity. There is again low correlation between health life expectancy and perceptions of corruption. And if you see these places, there is really high correlation between the happiness score and GDP per capita. Again, for social support also there is very high correlation. Now if you see, even for social support and healthy life expectancy, there is very high correlation, but there is low correlation between making life choices and generosity, and there is negative correlation between corruption and freedom of making life choices. You can see it is almost white color, which means it falls around this region, so negative correlation. Similarly, for logged GDP per capita and corruption, there is negative correlation. Alright. Okay, now we are going to visualize a bar plot that will tell us the corruption in different regions. So I'll just give a comment, corruption in regions. Let me just scroll down. Okay, so I'll create a variable called corruption, which will be equal to my data frame, that is happy_df. Now first of all, I'm going to use the group by function to group all my regions. So I'll say regional underscore indicator, which is my column name present in the data set, and after this I'm going to find the average of the corruption, that is perceptions of corruption. So I'm going to pass in my variable name, that is perceptions of corruption, and I'm going to use the mean function to find the average corruption in each of these regions. Now let me just go ahead and print my variable, that is corruption. If I run it, you can see here I have the values for the different regions, and from here you can see that Central and Eastern Europe has the highest perceptions of corruption as per the questions answered in the poll. And if you see the table, we have Western Europe and the North America region with the least perceptions of corruption. Now we are going to visualize this using a bar plot now. So first of all, I'll set my parameters by giving the figure size. I'll say fig size. It's rather figure.fig size. I'll just add figure here. Okay, and now let's say I'll assign it as 12,8. Now I'll give a title to my plot. So I'll say plt.title and my title of the plot is going to be perception of corruption in various regions. Alright, then I'm going to define my X label. So I'll say X label will be regions, and we'll set the font size of the X label to, let's say, 13, or let it be 15. Then we are going to set the Y label. In Y label I'll have corruption index as the label name. Again we are going to set the font size to 15. Now I'm going to use X ticks parameter. Since I want to rotate the axis labels in the x-axis by 30 degrees, so I'll say rotation equal to 30, and I'll say HA, which stands for horizontal alignment, equal to right. Make sure this right should be within single quotes. And finally I'll say plt dot bar, because I'm going to plot a bar graph. I'll say corruption dot index, comma, and then I'll say corruption dot perceptions of corruption, which is my column name. Alright, so I have my code ready for the bar plot. Now let me just go ahead and print the bar plot. Make sure everything is correct. I'll just hit shift enter. Okay, there is one mistake here. It says, okay, this should be X ticks and not X tick. Let me run it again. There you go. So if I scroll down, on the top you have the title, which is perception of corruption in various regions. On the x-axis you have the regions label, on the y-axis you have the corruption index. And if you see this, as per our table that we created, we have least corruption in North America and ANZ region. Then we have the next least corruption in Western Europe, but we have the highest corruption in Central and Eastern Europe as per their citizens' perception. Similarly, we have the second and third highest corruption in Latin America and Caribbean as well as South Asia. Cool. Now moving ahead, I'm going to show you how you can find the life expectancy of the top 10 happiest countries and bottom 10 happy countries. So for that I'm going to run you through the code and we'll see the visualization side by side. Okay, so I have my code written in these two cells. So first I'm going to find out the top 10 happiest countries, and then I'm going to find the bottom 10 happiest countries. So for that I'm using the head function and I have passed in 10 since I want the top 10 country names, and to get the bottom 10 countries as per their happiness score I am using the tail function. So let me just run it. So we have saved the result in two variables, top underscore 10 and bottom underscore 10, and to create the bar plots we are using two different codes. So here you can see I have set my figure size and axis, and then I have my X label as country name. After that I am setting my title of the bar plot to top 10 happiest countries life expectancy. I've used my X tick labels and I am rotating it by 45 degrees, and I have my horizontal alignment as right. You can see it here. We have used the bar plot function. I have the x-axis as country name and y-axis as healthy life expectancy column, and I have set my axis. Then I am using the X labels and Y labels as country name and life expectancy. And similarly, I have my bar plot for the bottom 10 least happy countries life expectancy. Let's just run it and we'll see the result. There you go. Now if I scroll down, you can see we have two different bar plots. The first one is for the 10 happiest countries, and then we have the bottom 10 least happy countries. So if you see, on an average, the top 10 happiest countries life expectancy is above 70 years. So if you are from one of these countries, you are expected to live for more than 70 years. Now if you check the bottom 10 least happy countries, you see here Lesotho has less than 50 life expectancy age, and most of them are less than 60 years. So if you are from one of the top 10 happiest countries, you are expected to live 10 years more than these countries that lie in the bottom 10 region. Cool. Now moving ahead. Alright, so now we are going to see the plot between freedom to make life choices and the happiness score. For this I'm going to use a scatter plot. So I'll first define my figure size. So I'll say plt dot rcparams, which stands for parameters. I'm going to pass in my figure size. So I'll say figure dot fig size equal to, let's say 15,7. Then using the Seaborn library and the scatterplot function, we'll pass in the x-axis. Let's say the x-axis is my data frame name happy_df, and I'll have the freedom to make life choices in the x-axis. So the column name is freedom_to_make_life and choices. I'll give a comma and we'll pass in the y-axis. Again I'm going to use my data frame name dot, and I'll have the happiness score. I'm also going to pass in a hue parameter to differentiate the different regions. So I'll say df dot regional_indicator, and I'll give the size of the dots or the bubbles as, let's say, 200. Now I'll say plt dot legend. I'll place the legend at upper left corner, so I'm giving the location, which is LOC equal to upper left, and font size, let it be 12. I'll say plt dot x label as freedom to make life choices, and my y label would be happiness score. Alright, now we have the code written for the scatterplot that I want to create. Let me just run it. There you go. So here we have the legend for the different regions, and we have the different colors for each of these regions, and you can see here I have on the x-axis freedom to make life choices, and on the y-axis we have the happiness score. So you can see it very clearly. For the countries that lie in the Western Europe region, the blue dots, the freedom to make life choices is more, and so is the happiness score. Then if you see the values in the green region, which is for Middle East and North Africa, the freedom to make life choices is lower, and hence the happiness score is also low. And for all these countries that are part of the sub-Saharan Africa, some of them have decent score for freedom to make life choices, but the happiness score is low again. Now if you focus on the pink dots, which is for the Southeast Asian countries, the happiness score is comparatively lower, but the freedom to make life choices is more than 0.8. Cool. And again we have one data point which is lying at the bottom. We can assume this is Afghanistan. So in Afghanistan the freedom to make life choices is very low, and even the happiness score is really low. Cool. Now moving to our next analysis, we are going to see the top 10 most corrupt countries. So first I am going to sort the perceptions of corruption column and find out the top 10 countries in the list. So for that I'm going to create a variable called country. I'll have my data frame name, that is happy_df dot sort_values by, I'm going to sort by column that is perceptions of corruption dot head, and I want to find the top 10 most corrupt countries as per the poll. And then I'm going to pass in the figure size. So I'll say plt.rc params, and then I'm going to set the figure size. So I'll say figure.fig size. Make sure there is no spelling mistake. Let's say the figure size is 12,6. I'll pass in the title. So I'll say plt.title. Let's say the title of my plot is going to be countries with most perception of corruption. After that I'll say plt.xlabel. In the X label I'll have country, and I'll set the font size to 13. Then I'll say plt.ylabel. In ylabel I'll have the corruption index. Next I'll pass in the font size for the ylabel. Again it is going to be 13. Now I'll say plt.xtix. I'm going to rotate it by 30, and I'll say horizontal alignment equal to right, and then I'll have my bar function or the bar plot function. So I'll say plt.bar. I'm going to pass in country underscore name, and then we'll have my variable country dot the column name, that is perceptions of corruption. Alright, now if I run it, you can see here, so these are the countries with the least perceptions of corruption. So Singapore has the lowest corruption index, and then we have Rwanda, Denmark, Finland. Now if you want to see the countries with the highest perceptions of corruption, you need to change this head to tail of 10. since we are sorting it in ascending order, so we would want to know the bottom 10 countries. If I run it, there you go. So these are the countries with the most perception of corruption. You have Slovakia, Lesotho, Kosovo, there's Ukraine, Afghanistan, Bulgaria, Romania and Croatia. All of these countries have a corruption index of more than 0.85. Cool. Now coming to the final section of this interesting video on happiness report data analysis for 2021, I want to visualize a scatter plot that will tell us how the corruption varies in terms of happiness score. So I'll just say a comment as corruption versus happiness. Okay. So first of all, I'll set my figure size. So I'll say plt.rc params. Within single quotes, I'll give the figure size as 15,7. Then I'm going to use the scatterplot function that is part of the Seaborn library. In the x-axis, I'll have my column that is corruption, or rather we'll have the happiness score in the x-axis. So I'll say happy_df dot column name that is happiness score. Let me give a comma, and in the y-axis we'll have the corruption column. So I'll say happy_df dot perceptions of corruption. And then in hue we'll have the region that is regional_indicator. So I'll say happy_df dot regional indicator, and I'm going to give the size of the dots. So I'll say s equal to 200. Then I'm going to say plt dot legend. I'm going to put it at lower left corner this time. So I'm giving my location as lower left, and the font size of the legend I want is 14. After that, I'll just say plt dot xlabel as corruption and plt dot ylabel as happiness score. Now this should rather be the opposite, since in the x-axis we have taken happiness score. So we'll put the happiness score label in x and I'll have corruption in y. Alright, so I have my scatterplot code ready. Let me just run it. There you go. So here you can see on the lower left I have the different regions, and on the x-axis I have the happiness score. On the y-axis I have the corruption index. Now you can see the general trend as per the scatterplot that the countries with greater happiness score have lower corruption index. So you can see these countries which are from the Western European regions have highest happiness score, and their corruption is also really low. So all these blue countries, you can name a few: Finland, we have Sweden, we have Belgium, France, Netherlands lying in these regions. We also have a few countries from North America and ANZ, which are essentially Australia. Then we also have Canada, US and New Zealand. Okay, now if you focus on these green region, this region, now these are the countries from the sub-Saharan Africa, and most of the countries from these regions have a very low or less than 5 happiness score, but the corruption is also really high. You can see here they have almost more than 0.7 in the corruption index. Now you also have a country here which is from the Southeast Asia. We would like to give you a task. It would be really great if you can tell us in the comment section which country is this. It has more than 6 happiness score, but the corruption index is really low, which is less than 0.2. Now if you consider Middle East and North African regions, the darker green countries, here also if you see, the happiness score is less than 5 and the corruption index is also high. Now there are a few countries, the Commonwealth of Independent States, for example countries such as Uzbekistan, then you also have Kazakhstan, we have Russia, Armenia belonging to these gray color dots. You also have Georgia and Ukraine as part of Commonwealth of Independent States. So here you see the corruption is below 0.6 for these countries and the happiness score is more than 5. Alright, so with that we have come to the end of this demo session on World Happiness Report 2021 data analysis using Python.
That's all for today's session. Thank you for watching the video. I hope you guys have understood how to analyze the World Happiness Report using Python. If you have any further queries regarding any of the topics covered, feel free to let us know in the comment section below and our team will resolve all your queries at the earliest. Until next time, stay safe and keep coding.